Welcome back to the Deep Dive, where we really try to take the complexity out of this cutting-edge tech and just deliver the essential insights straight to you.
Yeah, that's the goal.
And if you're tracking the progress of advanced AI systems, you know that the real magic, it isn't just the large language model itself, it's the architecture surrounding it.
Oh, absolutely. It's entirely about the plumbing and the management. Today, we've done a deep dive into the source material that details the difference between two foundational pillars of modern AI deployment: AI agents and the Model Context Protocol, MCP for short.
Right, MTP. And our mission here is to move beyond just the buzzwords. We want you to walk away from this with, the architectural clarity you need to understand how these systems actually scale.
Because they are both absolutely integral, but they do drastically different things.
Totally. You can almost think of it this way. One is the highly specialized self-directed contractor, the doer.
And the other is the standardized building code and the construction management system. It's the framework.
The framework, I like that. And understanding that dynamic, that relationship between the independent action and the systemic governance, that's the absolute key to deploying truly complex and reliable AI.
It really is.
Okay, so let's unpack this. Let's start with that self-directed contractor, the AI agent.
Right.
When we talk about an agent, we're talking about an autonomous operator. It's designed not just to process information, but to, actively change its environment.
That's the critical distinction right there. The sources we looked at define the agent by its ability to perform tasks independently, based on pretty generalized instructions.
So its core identity is autonomous action.
Exactly. It doesn't need a human to validate every single step in, say, a 10-step process. It just goes.
And that autonomy, crucially, is supported by robust tool use. It's not some closed box system.
Not at all. The source material really emphasizes its capability to make API calls. So if the agent's goal is to update a spreadsheet with financial data,
It knows what to do.
it knows how to call the right financial service API to get the data, and then it knows how to call the Google Sheets API to write in the new numbers.
And that functionality is just amplified by its ability to interact with the broader digital world through internet access.
Yeah, it can perform dynamic searches, connect to external services, browse the web, basically to inform its decisions in real time. This gives it the same operational surface area as a human sitting at a computer.
So it's not just reacting in the moment, though. It retains a history. It has internal memory and the ability to interpret and execute code.
That's a huge point. So if we tell it to handle a series of recurring, maybe slightly variable maintenance tasks, it actually remembers the context from the previous 10 times it did the job.
Wow.
And it can interpret those necessary code snippets for more advanced, more nuanced operations.
So it learns, it remembers context, and it acts.
Mm-hmm. Now, despite this impressive autonomy, this ability to act, to search, to manage a whole workflow, the sources are very clear on one thing. Human oversight remains a non-negotiable feature. And this isn't just, a regulatory suggestion. It's an architectural requirement to guide and intervene.
Especially when the agent is doing something high stakes, something irreversible.
Absolutely. If it's just writing a fun story, maybe you don't care.
Right.
But if it's interacting with your brokerage account through an API,
You definitely want that human tether. That's essential. So the agent is a sophisticated doer focused on achieving specific outcomes by interacting directly with its tools and its data.
precisely.
Okay, so if the agent is the master of self-service and direct interaction, what happens when that self-service needs to interact with an entire corporate backbone?
Well, now you're moving from the independent specialist to the systemic framework.
So let's look at the Model Context Protocol, the MCP.
Right, and this is where we shift focus entirely. MCP isn't designed for the execution of a single task. It's for enabling coordination in massively complex distributed environments.
So if the agent is that highly skilled contractor,
The MCP is the architectural standard. It's like a sophisticated enterprise service bus, but specifically for AI models.
okay, that's a helpful metaphor. But why do we need this specialized bus instead of just having the agent make standard API calls to every single service?
That's a great question. The sources define MCP as the system that becomes necessary when multiple, very diverse systems and protocols need coordinated transactional communication.
So one-to-one is fine, but many-to-many gets messy.
It gets very messy. Simple APIs work for one-to-one requests. MCP steps in when you need standardized communication, security, and this is critical context management across a vast web of clients and servers.
And structurally, The MCP host is the central brain of this whole operation.
Correct. The MCP host is the central hub. It's responsible for orchestrating all that communication. It handles the initial AI integration, like connecting the core AI logic that figures out the user's intent.
And connects it to the user interfaces, like an IDE or an interface for a specific tool. I think the sources mentioned Claude.
They did, yeah. So the host is like the project manager who receives the overall project scope from the user.
But I'm interested in that word context in the name. Model Context Protocol. What is the host actually doing to make sure the context stays intact as the task moves downstream?
Well, what's so fascinating here is that the protocol's job is translation and preservation. When a user or another agent submits a goal, the host ensures that the underlying context, so the user's intent, the session history, the current operational state, is all reliably packaged and translated.
So it prevents that kind of fragmented understanding as the goal gets broken down into subtasks across the network.
Exactly. It keeps everyone on the same page, metaphorically.
So the host packages the mission, then it hands it off to the clients. Is that how it works?
That's it. The MCP clients are the specific executors that carry out the tasks using that standardized MCP protocol. We see examples in the sources referring to clients connecting to specific servers, server A, server B, server C.
And these clients are basically just localized translators.
Yeah, that's a good way to put it. They ensure that the standardized request coming from the host is properly formatted for, say, a PostgreSQL database or a GitHub server.
And those connectivity examples are massive. I mean, Google Drive for documents, PostgreSQL for structured databases, GitHub for version control. These are not simple data dumps. These are critical enterprise resources.
And the ability to interact with those systems seamlessly for data exchange is what defines MCP. Its central role isn't execution. It's providing that standardized, reliable communication protocol.
So that every client interacts with its server correctly and the context of the overall goal is maintained.
Yes, it's the infrastructure. It's the rigorous system for communication. It's the orchestrator, not the soloist.
Okay, this clarifies the distinction a lot. So we have the sophisticated doer, the agent, and then we have the indispensable communication backbone, the MCP. But let's get specific.
Let's.
If the agent already has the ability to call the Google Drive API, why do we need the complexity of MCP just to access a document?
That is a great question, and it really highlights the difference between independent action and coordinated consistency. An agent can absolutely call a Google Drive API directly to fetch a document.
Right, that's a single transaction, a self-service operation.
Exactly. It's focused on its singular goal. But now, consider a scenario where your system needs to perform 3 actions that must be coordinated perfectly.
Okay.
An agent needs to simultaneously commit a code change to GitHub, query PostgreSQL to validate that schema change, and then archive the previous version of the code repository in Google Drive.
And all of that has to succeed or fail as one atomic operation.
Yes. It can't be partially successful.
That sounds like a classic distributed transaction problem from computer science.
It is. And the agent is great at deciding what to do. But when the execution involves highly scalable, wide coordination across these disparate components, especially when data integrity matters, that's where MCP shines.
So the MCP protocol manages the handoffs.
The handoffs, the session state, and it ensures the clients are talking to the servers using a unified, reliable language that can handle error states consistently.
So the agent is focused on the intelligence and the action, while the MCP is focused on the structure and the integrity of the transaction across all these different systems.
Exactly. The agent is the doer. The protocol is the framework that allows multiple doers to talk consistently to multiple mission-critical data sources all at the same time.
Okay, I think we've established they serve very different masters. But the real power, I'm guessing, comes when you put them in the same room.
And that brings us to the synergy, because you're right, these systems are designed to be complementary.
And this is where it gets really interesting, because the most powerful AI applications we're seeing are emerging when that autonomous action of the agent is housed within the standardized framework of the MCP.
That's right. We see that AI agents can operate completely autonomously, but within an MCP-based environment. The agent isn't just making random external requests. It's using the network that the MCP provides to interact with all these remote resources.
Let's run with a real-world workflow to make this concrete. Imagine a financial services company using this architecture to automate a weekly compliance report.
Perfect example.
A process that involves multiple secure systems.
Okay. So the MCP structure would first organize the environment. It would have clients connected to all the sensitive resources. One client talking to the brokerage API, another to the internal PostgreSQL compliance ledger.
And maybe a third client connected to a Slack notification service or something.
Sure, yeah. And the MCP host manages the context of this whole weekly report mission.
Okay, so the stage is set. Now, where does the agent fit in?
The agent is given the overall goal: generate the weekly risk report and flag any non-compliant transactions.
Is it a high-level goal?
A high-level goal. And the agent then operates autonomously within this coordinated system. It analyzes the risk parameters, it decides which data streams it needs from the ledger, and then it initiates the query through the MCP client that's connected to PostgreSQL.
And then it uses that same system to securely pull market data via the brokerage API client.
Exactly. So the agent is the decision maker. It's the strategist. It's autonomously determining the necessary steps.
While the MCP is ensuring that those steps are executed cleanly and consistently across all those separate corporate silos.
It's a perfect division of labor. MCP ensures the structure and the smooth, complex data exchange, and the agent executes the intelligent, task-specific actions based on the goal. And the source material highlights 3 huge benefits when you combine them.
Okay, let's break those down. First one, scalability.
Right, because MCP's architecture seamlessly integrates multiple clients and servers with a protocol, the system scales horizontally and efficiently.
So going back to our financial scenario, if the company acquires a new database or needs to integrate a new regulatory monitoring service,
You just add a new MCP client, and the agent can immediately access it using the same standardized protocol. You don't have to rewrite all the communication logic from scratch.
that flexibility is so key to future-proofing in architecture. Okay, what about the second point? Autonomy and flexibility.
Well, this is a direct benefit of having the agent in the driver's seat. Because the AI agent maintains the independent action capability, it's not waiting for some central authority to okay every single query. It dramatically improves decision-making speed.
And efficiency.
And efficiency. It can see the data, analyze the risk, and instantaneously execute the next query through the MCP system without any delay.
And finally, that robust integration with external systems.
This really connects everything we've just discussed. MCP ensures the system can access and utilize all these diverse external resources, Google Drive, PostgreSQL, GitHub, Quados, while maintaining that transactional consistency.
It's the infrastructure that lets the agent truly operate in the real world.
Yes, interacting with structured and unstructured data all across the modern enterprise. It's the key.
So when you look at it this way, the combination is, it's really revolutionary.
Mm.
MCP offers the reliable, standardized infrastructure you need for robust system integration and massive coordination.
Right.
And AI agents provide the necessary autonomous, flexible, and intelligent decision-making capabilities inside that framework.
Together, they deliver scalable, efficient, and robust, complex AI systems. Systems that are capable of seamlessly handling multiple, diverse tasks across totally different platforms.
Yep.
It is genuinely an architectural leap forward for enterprise AI.
It certainly is.
And, if we connect this to the bigger picture, it brings us back to something we touched on earlier: human control.
Ah, right. The oversight.
We noted that human oversight remains a necessary feature for the agent. But given the massive scalability that MCP's complex architecture affords and the incredible, rapid, autonomous action of the agents it hosts, well, this raises an important question for you to explore.
Okay, what's that?
What are the emerging challenges in ensuring effective and timely human control, the ability to intervene or audit, when the underlying architecture is specifically designed for maximum autonomy and complex, coordinated, multi-system operation across dozens, maybe hundreds of servers?
The faster the system runs, the harder it is to hit the brakes. That's a fascinating challenge to chew on as these systems grow. Thanks for diving deep with us.
My pleasure.
We'll see you next time.